around that time when atomic theory was being talked about, when Dalton actually proposed atomic theory, that was not the only thing that was happening. A lot of things were going on. Okay, a lot of things. I won't go over things chronologically because some things are irrelevant for this class. But I'll talk about some of the discoveries that will be useful for us. The first thing we're going to talk about is the discovery of electron. Electron was discovered in cathode ray tubes. Okay, and electron, the important thing about electron that you need to know is that it's found in atoms. It is negatively charged. Okay, it is negatively charged. Now, J.J. Thomson also proposed that the negatively charged electrons were small particles that were held in a positive charged sphere. Okay, and this is known as a plum pudding model, and this was at that point it was a very popular model, and this was the first atomic model. Any little bit of view of atom that they had, this was the first one. Rutherford, he took a gold foil, a thin foil of gold, and he scattered alpha rays on it. Alpha rays are positively charged particles. When he did that, what he found was that most particles just pass through the foil. Okay, and very few of them deflected at large angles. So what does that tell us about the model of atom, or what does that tell us about the interior of the atom? Think about it. Positively charged particles are being thrown on the atom, and most of them just pass through. What does that mean? That means that most of the atom is hollow. Most of the atom is empty space or hollow. And then there is something here, there is something in the atom which has really high density and which is making the alpha rays deflect at really large angles. So most of the atom is hollow, and there is something with high density in the center of the atom. Then neutrons were discovered in the nucleus of the atom. The center of the atom that we referred to in the previous slide is the nucleus of the atom, and neutrons were discovered. And one thing about neutrons is that they are neutrally charged, as in they don't have any charge. Okay, they have mass, and mass of neutron and proton is same. We'll get into numbers later. The neutron does not have any electrical or any charge. Hydrogen is the only element that contains only one proton, and it does not have neutrons. Every other atom has protons, neutrons, and electrons. So there are three subatomic particles that we're interested in: positively charged particles, protons; negatively charged particles, electrons; and neutrons that are not charged. Protons and neutrons have same masses, or not same, similar masses. Okay, and mass of electron is really small compared to that of protons and neutrons. And this is the table that compares charge and mass of protons, neutrons, and electrons. What you have to remember is protons are characteristics of elements. What do you mean by that? If there is an atom, and I'm just drawing a rough structure of atom, which contains in the nucleus protons and neutrons, and electrons are found in the outside of the nucleus. Electrons can be taken away or added to atom. Okay? That does not change the atom because characteristics of atom depend on the number of protons and not on the electrons. In other words, if you remove or add protons, again there is a lot of logistics to that, but just for us to understand, if you remove or add protons to a nucleus, then you are changing the nature of the material. You're not keeping the atom same.